Hello guys, welcome to Bosons Botany. Um, I have not uploaded any videos for a long time because I was extremely busy with my studies. So sorry for that. So here I am with a fresh new topic, or you can say extended part of stem anatomy, and I'm starting with dicot stem in this video. And the example that I have chosen is Helianthus or sunflower. This is a very common specimen to study dicot stem. So, if you recall the structures or the sequential arrangement of all the tissues, then it's same here as well, which are epidermis, cortex, endodermis, pericycle, vascular bundle, and pith. But some differences are there, and here they are. Epidermis, single layered, having cuticle. Many multicellular hairs are also present. So, multicellular hairs are present and cuticle present, and basically, cuticle hairs, these are protective structures, because I have already told you when I was dealing with root anatomy, I have already told you that root never has cuticle as its outer coating, because since the root is submerged beneath the soil, it is inside the soil, deep embedded, and it is of course not in direct contact with atmosphere, or any mechanical injuries are faced by roots. Very minor injuries are faced. For that reason, cuticle is not needed, because it is well protected down inside the soil. But for stem, protection is needed, because it is encountering with all the atmospheric particles, all the dust particles, all the mechanical stress which could affect the stem structure. For countering all those you know things, cuticle hairs are very important. Cortex, it has few layered collenchymatous hypodermis and a few layered parenchymatous general cortex. So cortex is basically divided into two main layers. First is hypodermis, which is basically composed of collenchyma, and the second part is general cortex, which is of parenchyma. Cells of hypodermis may have chloroplast. Oil cavities are present in the cortex, and if you know sunflower oil, about sunflower oil, so basically that oil is extracted from these cavities which are embedded deep inside the cortex, and this is solemnly present in case of helianthus or sunflower. Endodermis, distinct. Endodermis is present, having many starch grains, and that is why endodermis in case of helianthus is also known as starch sheath. Pericycle. Pericycle is multilayered. This is a common feature for all the dicot stem, and it is heterogeneous. Why? Due to the presence of parenchymatous as well as sclerenchymatous patches. Vascular bundle. I have already told you, repeatedly saying that vascular bundle is the main thing to distinguish between a dicot stem, a monocot stem, a root stem, whatever it is. So you all should understand composition or the arrangement of tissues um, by observing the vascular bundle. So just understand these points. Vascular bundle arranged in a ring, conjoint, collateral, open, and dark. And the terms, if you have watched my previous videos, I have repeatedly defining all these terms. So once more, I am telling you the definitions. When xylem and phloem in a vascular bundles are arranged on the same radius, then it is conjoint. And with xylem towards the inner side and phloem towards the outer side, then it is collateral in nature. And when metaxylem faces towards the periphery and protoxylem towards the center, then it is endark condition. So I think these terms are very well familiar, so I don't need to define them in detail. And cambium is present between xylem and phloem, known as fascicular cambium. Hence vascular bundles are open type, and due to this characteristic feature, all dicot stems are capable to show secondary growth. Why? Because they have open type of vascular bundle. And why open type? Because cambium is present in between xylem and phloem, and it is commonly known as fascicular cambium. Medullary rays are parenchymatous in nature, which are present as patches or parenchymatous tissues in between vascular bundles or in between two vascular bundles. So medullary rays are seen, which are parenchymatous in nature, present in between two vascular bundles. And the last structure is pith, which is very well formed and parenchymatous in nature. So here is the diagrammatic representation of helianthus stem, TS of a young stem in case of sunflower or helianthus. So as you can see, multicellular hair present, and all these hairs are unbranched without any branchings. The outermost layer is epidermis, and you need to draw this a bit thicker. The outline should be a bit thick for epidermis to represent the presence of cuticle. After epidermis comes hypodermis, which is as I have already told you, it is collenchymatous in nature and may have chloroplast. Then comes cortex, which is parenchymatous in nature. So you can put these two structures under cortex, because cortex is divided into collenchymatous, hypodermis, and parenchymatous cortex. Then comes the endodermis. It is represented with these wavy outlines here, as you can see. And endodermis is very distinct, having starch grains, as I have already told you. Then sclerenchymatous pericycle is present here, as you can see. And sclerenchymatous pericycle is basically present, as you can see here. This is phloem towards the outer side of phloem. If you observe this portion very carefully, sclerenchymatous pericycle is present towards the outer side of phloem, because just after sclerenchymatous pericycle comes the phloem, and then the cambium, and then metaxylem and protoxylem. Cambium is present in between phloem and xylem, and xylem is divided into metaxylem and small protoxylem. And this arrangement is seen all throughout here. And this is the pith, which is very very large, well formed, present in the center. So this is the diagrammatic representation. And now here comes the cellular representation. Well, this is multicellular unbranched root hair, stem hair. Cuticle, as you can see, it is dark structure, dark outline representing cuticle. Then epidermis, single layered, parenchymatous. This is collenchymatous hypodermis. This is cortex, which are cortex having parenchymatous cells, and oil cavities are present. As you can see, oil cavities embedded deep inside the cortex. Then endodermis is present. As you can see, it is very well marked here, and small dots are present, which are nothing but starch grains. Then sclerenchymatous pericycle, see, having double layers here, double outlines here to represent its thickness, its you know thick boundaries, because as you all know, sclerenchyma is dead tissue, and for that we need to represent sclerenchyma as thick structure. So sclerenchymatous pericycle is present. Then phloem, cambium, as you can see, it is very well marked here, cambium, separating phloem and xylem. And metaxylem, of course, very big hexagonal structures facing towards the phloem or facing towards the outer side. Then protoxylem, very small, hexagonal shape. And medullary ray, as I have already told you, medullary ray, parenchymatous in nature, present in between two vascular bundles. So this is a vascular bundle, this is another vascular bundle, and medullary ray is present in between two vascular bundles. Then the pith, it is very well marked here. So I think this diagram is very clear, and I hope that this video explains well enough about dicot stem. So I think that I should start with plant morphology, because I actually got this request long time back. So I need to start plant morphology, and then in some separate video collections I would definitely take up the topics of on secondary development or secondary growth in plant. So in this plant anatomy lecture, I don't want to start with secondary development or secondary growth. I want to take up all these sections in some separate video collections. So I think I should conclude plant anatomy. It has been a long series of plant anatomy videos. I'm really tired of uploading the same topic. So I need to change my topic now, and I wish to start with plant morphology. So thank you for watching.